Welcome back, everyone. We now begin the session 2 of our 6-day International Faculty Development Program on a pragmatic exploration of threat intelligence using edge and quantum computing tools. To commence this session, it's my pleasure to invite our respected head of the department, Dr. Rajaguru, to facilitate the gathering and share his words of encouragement. Sir, we warmly welcome you to address the participants in the gathering.
Thank you, ma'am. Good evening to all distinguished speakers, respected faculty members, and the enthusiastic participants present here. It gives me a great pleasure to be a part of this 6-day International Faculty Development Program on a pragmatic exploration of threat intelligence using edge and quantum computing tools, bridging academia, industry, and teaching practices. At outset, I would like to extend my sincere gratitude to our management for their continuous encouragement and unwavering support. Their vision and commitment to academic excellence have always inspired the Department of CSE to explore new frontier and organize programs of global relevance like this FDP. This evening session and indeed the entire FDP bring together eminent speakers and experts from academia and industry to share their insights on the evolving landscape of cyber threat intelligence, edge computing, and quantum technologies. We are truly privileged to have distinguished professionals with us whose knowledge and experience will surely enrich our understanding and spark a meaningful discussion that connect theory with the real world practices. To all our participants, I encourage you to make the most of these sessions, engage actively, and carry forward learning into your teaching and research endeavors. Once again, my heartfelt thanks to our management, all the speakers, and the participants for making this FDP a platform of knowledge, collaboration, and inspiration. Thank you all, and wish you the remaining sessions continued successful and fruitful learning for everyone. Thank you all.
Thank you, sir, for your inspiring words. It's now my pleasure to introduce our distinguished speaker for the session 2, Mr. Karthikeyan Ilangovan, the Director of Digital Transformation, St. Alberta, Canada. Mr. Karthikeyan Ilangovan is a distinguished technology leader and Director of Digital Transformation at Bally's Interactive, a leading global gaming and entertainment company. With over 15 years of extensive industry experience, he has been at the forefront of driving large-scale digital transformation initiatives, seamlessly integrating the technology, people, and processes to deliver impactful business outcomes. A TOGAF certified enterprise architect and blockchain enthusiast, Mr. Karthikeyan has architected and implemented enterprise-grade solutions for diverse global clients. His technical expertise spans C#, .NET, SQL, React, Angular, Node.js, and cloud technologies, and is widely respected for his innovative approach to enterprise and solution architecture, cross-platform systems, data analytics, and portfolio management. An alumnus of our Anna University, he has built a strong reputation as a rational leader and passionate technologist, known for his commitment to excellence and his ability to translate strategic vision into technology-driven transformation. We are truly delighted to welcome Mr. Karthikeyan Ilangovan, a dynamic professional and inspiring leader, to share his insights with us this evening. We warmly welcome you, Mr. Karthikeyan, to share your insights with our participants. Now, the virtual stage is yours. Thank you. Thank you for joining us.
Thank you, Dr. Shamim. Thank you all. Thank you all for making this time. Faculty, so just a quick intro, I guess. Shamim did our introduction, but from my end, I'm Karthikeyan Ilangovan. Director of Digital Transformation. I've been in the industry for almost like 20 years. When I say industry, in the software industry, I've been with this one for almost like 20 years now. And majority of my career has been with gaming. When we talk about gaming, these are not like PlayStation, Xbox type of gaming. These are like real world casino gaming. You walk into a casino, you play in table slots, that type of a gaming industry. And I've worked across India, UK, Canada, Asia Pacific. I've dealt with diverse customers, diverse products, diverse problems. And that's where I have my own interest in cybersecurity, and that's where the synergy is happening, right? So, um, why cybersecurity in gaming? If that's your question in your mind, we are similar to banking in a way. We kind of deal with, if not billions, I mean millions of transactions, millions of funds goes in and out every single day. If you take a casino in a remote place like near in a small island near Hong Kong, there's a place called Macau, and one casino there deal with almost like $30 million every single day, right? So that much amount of transaction goes in and out. And if you look at any of these casinos or any online casino space, I mean, the average player base is almost like 3 million to 4 million customers. So there's a ton of transactions going in and out, and as well a ton of funds going in and out. And there's obviously a need of cybersecurity to make sure we secure the funds, we secure the player information, as well as we kind of comply to the regulatory standards and all that. So that's a high level intro of myself, team. Let me bring up my screen here as well. Let me know once you guys start seeing the screen. You guys are able to see my screen now? Shamim, can you please confirm if you can see the screen?
Yeah, I mean, we are able to see right now.
Awesome. Yeah.
Yeah, thank you.
All right, team. I'll quickly jump on to the topic itself. So before I jump right into it, I just want to quickly get some thoughts from this team. You can just post it in the chat as well. So what do you guys think about cybersecurity at a high level, right? So is your mind going towards someone hacking the system, stealing data? What is in your mind when we talk about cybersecurity? If you could just put some thoughts in the chat while I keep going on, in the interest of time. Right. So this is what we'll cover today. At a high level, we'll be talking about the threat landscape, the common threat detection models in the industry as of today, and COTS tools used in detection, geolocation and spoofing, attackers, TTPs, and automation, right? So TTPs are nothing but the tactics, techniques, and the procedures typically attackers use, and how it is automated from their end as well as from our end. And we'll also touch base on how quantum is evolving in the space, both from attacker side of things as well as from operator side of things. Team, please make it a little interactive so that we can benefit each other. Okay. So please ask your questions if you have any. Um, any questions? I mean, before we jump right into the details of all this landscape aspects here.
Dear
I think Ganapati,
participants,
you're in mute, I guess. Yeah.
Sir, I am Dr. Ganapati, professor from Dr. MGR here. Actually, my doubt is any cyber threat which is happening in government sector, for example, revenue department or something pertaining to India or Canada, the modus operandi is same or it will be different type of things?
Depends upon the industry itself, Mr. Ganapati, right? So, what is that's where the TTP comes into picture. The tactics, what is the attackers trying to achieve? I believe in India it is more of. I don't think it is different from the region itself. Rather, it is different from the purpose of it, right? In some situations, the attacker is trying to just literally steal the customer data, right? So let's say in your case, in the government sector, per se, I mean, if the attacker can get
Because
all of
CM's
residential
website
information.
completely hacked actually. CM, Chief Minister website was hacked completely.
Exactly, right. So that type of an attack is called takeover attack. They actually bring down the system, and then they claim a ransomware to bring it up to
Yes.
release the system, right? So that's called a takeover attack, account takeover or system takeover type of an attack. That is just to defame a particular entity. In this case, the government entity is getting defamed. That's telling that we are very powerful than what you are. We could do whatever we want. It's more of showing their supremacy over the government, right? But in certain type of attack, it could be more of ransomware as well. So we brought down your system, you give us $1 million, then we'll release the system. So it
Thank
could
you,
be
Karthik.
different.
Thank you, Karthik. You
Yeah,
can
yeah,
continue,
yeah,
please.
yeah. Already. Any other questions, team, before we jump into the details?
Yeah,
All right.
participants, do you have any questions? Please, you can post it in the chat box, or you can unmute your audio and video and we can proceed.
All right.
Good evening, sir. My name is Sangeeta.
Mhm.
I just want to ask you a question. What would you say is the main difference between a cyber attack and a cyber
Mhm.
threat? And how do you see the cyber attack or threat happening often right now in any scenario as such?
I think we are right there. I mean, talking about how often it is. Cyber attack threat, it's one of the same, Sangeeta. I mean, so attack is a byproduct of the threat. So we anticipate a threat and then be prepared for it, and we block attacks. That's the life cycle of it, right? So every single industry out there, if you have an online presence, you have a cyber threat. Be it your college, be it a government entity, be it a bank, they all have the cyber threat, the threat of being attacked. And then you protect yourself, and there are vulnerabilities even though you protect. And then some hacker sitting in a remote part of the world will attack you, and then your systems could block it or let you and show your vulnerability. And that's a process of it, right? So we are actually right in that slide talking about the landscape of the attacks, right? So there are like multiple types of attacks. We cannot just cover everything here, but I just try to bring in the summary of it per se. So at any given point, I mean, based upon some statistics, we are looking at if a breach occurs for an entity like a bank or any other entities which deal with financial transactions, the minimum average cost is about $4 to $5 million. Once the breach occurs, if it is a ransomware attack, we have to basically give money to the attacker to release the stuff, or we identify there's a vulnerability and then we address the vulnerabilities, which is going to cost us from infrastructure, tools, system, processes, people. That would cost the money. So, long story short, if an attack happens, in an average, a company would have to spend $4 to $5 million to fix it and then make sure it doesn't happen again. And I mean, at least in recent times, right? I mean, I don't know if it is a COVID effect or anything else, or maybe just the technology is booming. Since 2020, the industry is seeing almost like 300% bot-based attacks. This is the most um, pertinent and most widely seen type of an attack right now in the industry. We'll talk more about that bot type of an attacks here in a bit, but we are seeing like 300% increase in bot attacks since 2020. And malware, we all know what malware is. You get a fraudulent email, you click it, something is downloaded to your laptop, and from then it is passively sitting in your laptop or your computer and then trying to steal information like passwords, usernames, and all that, right? So, and then there's an average time gap between ransomware steps, meaning every 11 minutes. It's similar to someone kidnapping a person, and then they try to hold you on online to get money from you, right? So similar to that, exactly similar to that. I have been in such a situation in my company once, where our data was held by a ransomware attacker, and then we have to deal with it in a way. I'll talk about that as well if time permits later. So that's the landscape, guys, man. And then quickly jumping on to the type of attacks. DDoS is one of the common type of attack. It's distributed denial of service. It is very, very simple. Any system, any system that we have, any website that we have, let's say you have a student registration form, I am 100% positive uh, someone with a very basic knowledge of how to do a DDoS attack can actually bring down that application right now. It would be definitely vulnerable. So that's how vulnerable pretty much every single system out there is currently is. What it means is they simply go to the website. I don't know how many of you are aware. If you actually go to any browser-based application, or in today's world, even mobile apps, native mobile apps like that runs on Android or iOS will also be vulnerable to these type of attacks. All they have to do is have to inspect. I don't know if you guys are aware, you just go to a website, you right click, and there is an option to inspect that brings up the developer tools. I'll show you if you guys want to see that. So one moment. So let's say I'm just trying to book a ticket here. Let's say I go here and you right click and then inspect. I don't know how many of you tried doing this. So pretty much it tells every single API calls that goes in and out. I try to log in, there's a bunch of API call that goes to the backend system. Every single system, in a way, it's like a client-server architecture, right? So this is the client, and then you go to the server to do some transaction. When I try to log in, I'm typing my username and password. If I'm able to find what API is being used, so it pretty much tells you every single call that goes from the client to the server, right? So if I'm able to get the APIs that is being used to log in a person, sign up a person, and then to get the flight information, all I need to do from there is try to see if that API is vulnerable. If that API is not having enough security, then there I go. Then now I'll be able to do my whatever type of attack I want, right? Where I'm getting at is most of the applications that is running out there right now may not be having the sufficient protections to prevent these type of attacks. So DDoS attacks is a very, very common type of an attack and easy to do as well. Phishing, we all know, you get a deceptive email, you click it, and then from there on, it starts tracking your browser activity. You'll be able to they'll be able to get your credentials and all that, right? Ransomware, we're talking about it. So somehow the attackers will try to send a malware or a malicious software to your server and to your system, to your laptop, and from there they'll be able to their when it comes to ransomware, their intention is not to actually steal anything, but to actually block your business from running. So they bring down this. I guess one of you brought up a situation where the CM's website is brought down. That's a ransomware type of an attack. They bring it down and then they claim ransomware to release the software or release the application, right? And man in middle of attack, man in the middle type of an attack. So this is very this is also another one which I guess you would have seen it as well. Sometimes we'll be told that okay, a banking website uh, will be a link will be sent, but if you look at it, it'll look like a banking website, but there'll be a small typographical error in that. And if people mistake it for the bank, for example, HDFC, there'll be a small character added to make it look like a different make it look like the bank website, but it's actually a different link altogether. People mistake it for the bank. They click it, they enter the information, they enter the username and password as they normally do. But what is actually happening is the man in the middle. This is a fake website. They're actually capturing your credentials and using it in the actual bank. So that's a man in the middle attack. Um, SQL injection. This is quite common as well. This has been there for almost like uh, as old as I am, 30 years, 40 years. This is very common type of an attack. So any vulnerable APIs, they send a script because most of the developers, when they're developing the system, they just take the request, and then pass it on to a backend system that uses that in a query to fetch some data. So SQL injection, basically, when they try to do the attack, they basically send a query as part of the request, and this query sits in the query in the actual processing, and then returns data more than what it should. That's basically used for stealing data, right? Social engineering. This is a very cunning type of an attack where they take multiple processes. There is actually a human involved. They call you. They talk to you as if they are calling from a bank or from the government, and somehow trick you into providing more information, and eventually get money from you or bring down the system or something like that. So this social engineering attack, if I have to give you an example, literally happened in one of our customers' place. It's called as MGM Resorts. They're a huge casino operator. They have like about 19, 20 properties across the US. Very simply, someone called their IT. They called the front desk, and somehow they got connection to the IT department and had them reset the password of a server, pretending as if they are calling from a legitimate vendor. So they trusted the vendor. So they trust the vendor. So they believe this person because they're claiming they're the vendor, and somehow reset the password. And now they reset the password. They took over the entire database. That blocked the casino operation, the hotel operations. Pretty much everything is blocked for almost like 10 days. And it took them $36 million to recover from it. That's a social engineering attack. That's how serious it is as well. Credential stuffing. Um, it's another if each one of us in this call would be actually a victim of credential stuffing. If you actually go check I think Gmail has it as well. If you try a common password, a very easy to crack password, it will say this password is part of an excluded list, meaning this password is already exposed. Try using a different password. I don't know if you guys have encountered it. We have seen it quite often. So what happens is somehow using some of the attacks that I mentioned before, um, these hackers will be already having a database of username and password, common username and password. They'll be having a huge database of it, and they simply try a brute force with all this. If they try to get a link, a bank login link, they just try all those username and passwords and see if they can actually get in to any of account. It's simply like going around the parking and then seeing if any car has anyone forgot to lock their car and simply try to open the car, right? So it's as simple as that, but it is very, very common. Supply chain attack. It is another type of an attack which is quite serious, where they don't attack the actual entity, but they attack the vendor that the entity trust. I don't know if you guys are aware. I mean, recently, like 2 to 3 years ago, we had an issue with SolarWinds. So SolarWinds is a company or a product that takes care of your infrastructure. They can actually take care of your infrastructure, maintain it, monitor it, and all that. So they injected a malware into SolarWinds and eventually bringing down any company that used SolarWinds. It's like a worldwide impact that happened like 3 years ago. I can keep going on, team. So that's pretty much the landscape of cyber attacks. One other one that I want to talk about is a zero-day exploit. Um, this one happened with I think this happened with Cloudflare. Um, like exactly like 2 years ago, this happened, and then this also brought down pretty much every single system that was running a Cloudflare as their web application firewall. So this is another serious attack. The reason is we we want to protect ourselves, and then we rely on a supplier or a vendor who provides in top-notch security mechanism for these type of attacks. And what if that vendor is attacked? Everything is going down, right? So that's exactly happened with Cloudflare and Microsoft during the zero-day exploit. So somehow the attackers exploited a malicious, not a malicious, but uh, an incorrect patch on Microsoft that was in turn used by Cloudflare, and that brought down Cloudflare, and eventually every single system using Cloudflare went down as well. We cannot reach it because if the web application firewall goes down, no one can enter into any systems, right? So that's what zero-day exploit is. Right. That's ton of information, team. Any questions before we move on to the next one?
I guess we can move on.
Awesome. So bots, right? So bots are interesting entity in the cybersecurity landscape. So when we talk about bots, what are they? What are bots, right? So we just call it bots because they are autonomous. They just operate by themselves, and not just autonomous. They operate in scale. As of today, almost like 50 plus percentage of the traffic that is happening in the World Wide Web right now is by bots. Only the remaining 50% is actually humans trying to access it. The rest of the traffic is all bots. So what does bots do and how they operate? These are basically automated scripts that just run in a remote server somewhere, and they try to take advantage of proxies. You will not be able to trace where these bots are running. You'll not be able to trace which particular server these bots are running from. So they'll be hopping on between multiple onion routers. These onion routers are like VPNs. So they're not just one VPN, but they'll be having multiple layers of VPNs. So you'll not be able to trace where these bots are running from. And they just run in scale, right? So they run in like they simply try to scrape every single website out there and then see if there is any vulnerabilities in the API. As simple as I went to the website, I did an insight, and then I was able to see all the network traffic going in and out of the website. That's exactly what the bots do. They have automated scripts, Python-based scripts that just scrape through all the websites, not every single website, but websites that are that might have potentially valuable information, like banking websites, or in our case, gaming websites, or industry like government websites. They just scrape through, find vulnerable APIs, vulnerable information, and try to steal that. Out of the 50% that I'm talking about could be all bots. Not all of them are bad. Few of them could be good bots as well. When I say good bots, these are like service-based bots. For example, I don't know if you guys are aware, there's an app called Skyscanner that simply scans all the airline tickets and tells you which one is cheaper. They actually use bots. They actually simply go to the websites. They go to Air Canada, they go to Air India, they go to Air France. They simply scrape all this data and then finds out which one has the most cheap ticket from one point A to point B. That is also a bot, but those are harmless service-based bots. But that's only out of the 50, you can say 12 to 13% of them are good bots. The remaining 37% are actually bad bots. I've seen it myself. So in our websites where players can actually go in and register themselves and place betting and all that, if we don't enable bot protection, or if we enable bot protection, we can see almost like 30 to 40% of the traffic is getting blocked right away. All these 30-40% are all bots. They're simply trying to see if there are any vulnerabilities, and then once they see there is a vulnerable API, they try to do parameter pollutioning. The parameter pollutioning is a term that we use in industry. What they simply do is they keep a track of all the possible parameters that could go in, and then try random parameters to see if any of that works, and then try to get into the system. That's what these bots do. Right. And there is a trend as of 2025, there's almost like 47% of, sorry, no, 47 million DDoS attacks that is happening. And using tools like Cloudflare, CrowdStrike, and a few other tools that we can talk about, it is getting mitigated, but industries who think they're not vulnerable or who think they are protected, they are still out there vulnerable and might get attacked by these attackers and the bots. Right. I'll take a quick pause there, team. Just want to see if I'm in alignment with what is the expectation. Dr. Shamim, if you could tell me if this Is this what you're expecting to see, or
Yeah,
are there any other additional information that you
Yeah.
guys are interested in?
we are on the right track. The
Awesome.
previous session was about the academic foundations, and the next session is completely about the industry, which actually was our plan to bring out for the participants.
Awesome. Great. Yeah.
Okay, that's great.
All right. Yeah. So before we jump onto the threat detection models, I know one of the topic is related to quantum computing in cyberspace. It is a bit of a leap, to be honest, team. We have not started using quantum computing in preventing attacks, but we have been actively exploring that space. The reason is it is not a tomorrow problem, it is already a today problem, right? So um, we kind of are aware that countries like China, Russia, they already decrypting every single communication going in and out. For example, we could say the messages getting transacted through WhatsApp is encrypted. But if the traffic is going through China, Russia, they will already be able to decrypt it, and then they scan it to see if there's any politically diverse messages going in and out, and they can actually store it and act on it. So they are using quantum computing for it. So why quantum computing is the leap? Because whatever traditional computings could do in like 300, 400 years, quantum computing can do it in minutes. They can actually process transactions. Quantum computing would actually bring in the true parallel computing. What we do as a parallel computing today in the current world is all pseudo parallel computing, right? So you all know to actually process multiple transactions in parallel, we need that many processors in your PC. You can say I have a 5-core PC, but you can technically process only 5 transactions at a time. But to decrypt or to hack an RSA algorithm or a TLS certificate or a HTTP connection that is secured with HTTPS, you would need with that type of a processor, like a monolithic single processors, you would need pretty much the age of the universe to crack it. But quantum computing truly can crack it within like a few hours. So that's the leap, right? So we are talking about not like 50, 100% leap. It's like billions of times leap with quantum computing. That's where it is very, very dangerous from an attacker standpoint, as well as, primarily from an attacker standpoint, right? So there is quite a bit of uh, development happening around that space, but it has not become commercially usable solutions yet. And that's where we are not seeing many quantum-based attacks, because it's very expensive to have a quantum system. And we don't think that is still possible for an attacker to acquire it, but it is not going to be too far, right? So we spoke about machine learning and large language models as a theoretical subject 10 years back. Now it is in everyone's laptop and it becomes a de facto. So quantum computing could be that in the next couple of years or even within the 5 years. So it is good for us to get prepared for it. So that's pretty much on the quantum computing. So there is no active, at least from my zone, we are not doing active quantum-based threat detection models or quantum-based. We are not seeing quantum-based attacks as well, but it is definitely coming in right there, right? So it is good for us to get prepared for that as well. Coming back to the threat detection models. So what you mean by threat detection models is it is a framework of how we actually tackle the threat as well as tackle the attack, right? So it is for operators, businesses, and their SOC teams. SOC are nothing but security operations committee within every single organization. They'll be following certain frameworks to tackle these type of attacks. One of the most common one is the MITRE attack. MITRE is a corporation. They are an NGO, so non-profit organization, and they came up with this framework called ATTACK. ATTACK is nothing but adversarial tactics and techniques and common knowledge. Basically, what they do is they digress what is the tactics that is commonly used by the attackers to actually infiltrate into any system, and techniques they follow and the procedures they follow, right? So once we have that information, it will be easy for us to prevent or mitigate the threat, as well as if the attack happens, how do we come out of it? It's more of a playbook. Mirror attack is more of a playbook, and it is imminent. If when you talk about the difference between academia and the industry, so these are the key differentiators. So students coming out of college, if they want to get into the cyber threat landscape to become an expert in the cybersecurity world, they should be having a good knowledge of these type of models that is already being used in the industry. Mirror attack is one very common model that is being used. Next is Cyber Kill Chain by Lockheed Martin. So Lockheed Martin is actually a defense manufacturer for the US. They produce F-5 jets, they produce missiles and all that. And they also help the government in terms of these cybersecurity type of solution, right? So they recommend a 7-stage model. Basically, their philosophy is every attack will go through these 7 steps. The reconnaissance, weaponization, delivery, exploitation, and installation. Installation, command and control, action, and objectives. So what it means, the first step, the attacker reaches the target. Somehow, it could be any form, right? So as simple as we would have heard about in India, I think it is in India, is quite common. So someone calling an older person and then telling, okay, so we are calling from the bank, you'll be getting an OTP. Can you share that OTP? That's a very, very basic type of reconnaissance. So they somehow know this person is alone and they are aged and they don't have much of knowledge on technicalities. So they are a good candidate for us to exploit. So that's reconnaissance. They find the weak spot. That's the very first step. And the next is weaponization. They create a malware exploit or send a somehow try to get infiltrate into the system itself. If it is a business which is run not by and they don't have a good SOC team to take care of all this, so they could be a good candidate for these attackers. They either send an email and ask them to click it. While clicking it, something gets downloaded to their server. Once it goes into the a laptop, into one individual's laptop that is connected to the company's network, every single company has this model, right? So they have a laptop and that is connected to the local network. I guess in the college as well, you'd be having a laptop that connects to your college's VPN. Once something goes in there and the VPN is not secured enough, they can easily transfer some command and control to other servers within your VPN network. So that's what weaponization is, and then goes the rest of the story, right? So delivery, exploitation, installation, C2. C2 is nothing but command and control, and finally action and objectives. What they actually want to do. They could bring down your system, they could steal data, whatever it is. So the philosophy of cyber kill chain is in the 7 steps. If you could break or kill the chain in any of the steps, I mean, either it be weaponization or delivery, then we are protecting. Even though the rest of the steps could be very sophisticated from the attacker standpoint, but we are preventing it from spreading beyond that, right? So it's as simple as that. Where we stop, where we have more control, where we invest in more, in which part we want to actually prevent the attackers from going further. That's cyber kill chain. It's again a framework. And diamond model, it's a similar framework, but they categorize, their approach is more of categorizing an attack in four entities, like who did the attack, what are the capabilities, what is their infrastructure, and who are they targeting. So once we model the attack in these four pillars, then it is easy to mitigate the attack or probably come out of it, right? So it's basically a model, a framework to deal with such threats and attacks. The last 3 are quite interesting. I'm going to spend a little bit more time on them. Quick time check. I think we are close to 7 more minutes, right, Ashaman?
Oh, we have time. It's 8:30 only here. I think it's getting late for you. We have 20 more minutes.
Awesome. Yeah, perfect. So behavioral analytics, user entity behavioral analytics, what it means is this is where most of us will be sidetracked. What we will be focusing on traditional bots, DDoS type of an attack, and then we leave behind behavioral analytics. But this is becoming quite a positive trend in the industry. What it means is um, a transaction could appear legitimate. It could seem as if true customers are logging in, they are trying to do some transactions and all that. But behind the screen, the attackers have become very sophisticated. They pretend as if they are legitimate individuals trying to access the system, and but their intentions are to actually steal and then do some sort of damage to your business, right? So the tools that we are building and tools that are evolving in the industry is to track these type of behavioral and these type of behaviors and then protect it. I'll give you an example. In our industry, what will happen is, so ours is a heavily regulated industry. For example, if you are in a state of Pennsylvania, you cannot um, you cannot log into our application and place a bet. But if you travel to New Jersey, yes, you can. But inside Pennsylvania, not supposed to. This is a very common regulatory requirement that we have. So what attackers do or exploiters do is they somehow spoof the system. They come through a VPN that is installed in New Jersey. They'll be the person will be in Pennsylvania, but they will access the system through VPN installed in server installed in New Jersey, and then come through as if they are from New Jersey, basically trying to surpass the limitations that we have. But how we identify is, so to access the system, the first they have to log in. So the login IP would be from Pennsylvania, but the rest of the transactions will be from New Jersey. It is very unlikely someone could travel that fast. So we detect the IP switch, we detect with the origin, and then say, okay, these type of transactions where the login and the actual transactions coming from a different geographical location is definitely something like looking like a fraud. So we flag those transactions, will not let the player to continue on. This is one basic example that I could give. Um, you'd all seen this type of behavioral analytics used in your regular day to day as well. Often, if you notice, there is something called captcha that we use, that we enter while we entering banking information. Some captchas, if you notice, they'll just ask you to simply click on something. It's not complicated. A bot could actually move the cursor and click it, but they still know. I'm talking about examples where are you a human type of a question. It's a very common captcha that we see nowadays. It's a very simple thing. Our obvious question is, when I can click it, why not I develop a system and develop a small bot that can do it as well? Why this simple question, which is quite obvious? But it's not about us moving the cursor and clicking it. It's about how we actually move the cursor. If you notice my cursor here, a human would not be following a straight path direct to that. Even if I follow a straight path, it is very unlikely it is exactly in that pixel angle and then clicking it. But if a bot does it, the bot will actually traverse through a straight line, exactly a straight line, directly to that checkbox. They track that mouse movement and then detect whether it is a human or a bot. That's the story behind that simple "Are you a human?" captcha that we used to have in most of the applications, right? That is behavioral analytics. We have systems in place in our industry where we see if the device is used by a person, or is it simply a device form, by monitoring the device angle, how they're holding the device. Is the device always being static, and how often they're getting calls in the device, how often they're using different applications in the device. We monitor different behaviors and then detect whether it is actually a human, or is it a bot that a hacker is using to get into the system. That is behavioral analytics, and we use machine learning a lot to get this data, to get this patterns, and then track it, and then find out what type of a source is it. Risk-based deduction, we put a score for every single parameter, starting from the profile itself. We check if the phone number has any presence in malicious websites or dark web, an email have any presence, when that email was created. Based upon all these parameters, and if the person is convicted, have they ever been in a legal case, we use all this information and then put some scores against the player, not the player, the customer, and then determine if there is a potential of this person, this entity being a fraud or not. That is risk-based approach. Zero trust architecture. This is the most recommended architecture for any financial institutions, either it be bank or gaming or any other institution which deals with finance. What it simply means is never trust any device, never trust any single user. Always go through all the security procedures, right? Even if you just logged in today morning, you try to log in again, it will still ask you to enter an MFA. It will send you a notification to your mobile. You copy the code and you enter the code that you see in the mobile into the application you're logging in. And if you noticed in Gmail, if you enable all the security options they provide you, they can track which device it is being logged in. You'll get a notification that we see your account is being logged in from Singapore. Is that you? You could have actually traveled to Singapore and logged in yourself, but it will still send a notification. That is zero trust policy. That is the most recommended architecture that's being followed in the industry right now. All right, I'll take a pass, team. Any questions?
Questions from the participants? You can post it in the
All right.
chat box or unmute yourself and post your questions. We shall proceed.
All right. I'll move on. Shamim, if you could keep a track of the questions, I'm not seeing the chat.
Yeah,
so if there's
sure.
any questions that I need to answer, please pass me.
Yeah, sure.
Yeah. What you guys see on the screen is actually just a glimpse. I've been talking for a long time, so I want to show something interesting. This is actually a real a dashboard from our industry that we use to monitor every single traffic that is going in and out. What you're seeing is actually not a live, I took a screenshot, but it is a real dashboard that we monitor in the real world, right? So what you see in this this flower-like thing is actually device access from across from all our users during a particular time. So we detect patterns if these accounts, if you see the red lines, these could be connected identities, meaning it could be the same person or people sharing the same type of an identity. For example, they could use if I'm an attacker, what I would do is I'll try to create fake driver licenses or somehow spoof information or steal information from others and try to log in with that. So we detect similarities in this ID, and the system that we use will highlight these accounts that logged in from during this particular time period seems to be having similar IDs. Do you want to go check it? So we do further investigation on these accounts and see if those are actually attackers or could be legitimate accounts as well. But this one helps us to flag those accounts. If you look at it, the top one, multi-account device IDs, meaning these devices, the same device, we could see multiple accounts are accessing. So for example, a legitimate case could be my wife and I are using the same device. That is a legitimate case. It could be a very common thing. But if there are more than that, if there are more than 5 people using the same device, that is something to flag. There could be a potential attacker using a device form or a simulator to get into the system or trying to hack the system. So these type of dashboards will help us monitor it constantly and then highlight it. And then our fraud analysis team and the security operations team will dwell into this into further detail to find out whether these are fraudulent accounts. And what you see in the right is actually again another dashboard to tell us what is the trend of the traffic. If you look at it, I quickly go to the end. There are about 92,000 sessions scored during a particular, I think this is for a week. So in a week, we have about 92,000 sessions scored, meaning we track 92,000 sessions, and then we put some scores for all these sessions. Some sessions could be good, they are legitimate, so the score will be quite low. But if some sessions like the one that you saw in the right, saw in the left, could be fraudulent sessions, we put some high score on it, depending upon what type of vulnerability we are seeing then, what type of suspicions we have. So for example, the multi-account device IDs that we saw, those transactions will be scored high, so we can actually get into more details there. So all this, in this period, we saw about 3,870 transactions that could be highly risky, and 252 login attempts which could be a emulation, meaning emulators are another critical thing that we are tackling. Emulators are nothing but we use that in our regular development as well. If you want to actually develop an app, a native iOS or an Android app, we will not be having every single model out there to test it. So what we do is we use something called an emulator. So it emulates as if it is a real device. I might be having an iPhone 16. I may not be having an iPhone 12. So this emulator allows me to test the product in iPhone 12 as well. This is used in a legitimate setup. We use it in our development and all that. But attackers do this too. They emulate as if they're coming from to show the diversity. If all the request is coming from iPhone 16, then we know there's something suspicious there. Very unlikely every single user will be having an iPhone 16. So to show the diversity, they'll be having few transactions coming from iPhone 16. The same IP will be having a device with iPhone 12, iPhone 10, and all that. So that's a red flag for us. We'll stop right there and then say, okay, why multiple device types are coming from the same IP or same IP range, and we dwell into that. So that's emulators. We saw within this period about 250 transactions coming from there, and so on, right? So that's how typically companies kind of monitor in a day-to-day operations, right? So we have teams that look at this every single day, and that's their regular job. We call them SOC teams, Security Operations Committee, and we have red teams. Once a SOC team finds a threat like this, they actually give it to the red team. The red team is the one which they will try to simulate the same type of an attack and see if there is true vulnerability in the system, and then they will come to us to fix it. So that's come to the developers to fix it. That's how the setup will be typically. The SOC team, red team, and then they come back to the engineers to fix it.
Excuse me, Mr. Karthikeyan, there's a question.
Yeah.
From the audience.
Yeah.
What are the techniques available for public auditing with privacy preservation?
So privacy preservation, I think, okay, so all this threat detections and models in place, one of the key entity that we're trying to prevent is privacy data, personal data, right? So any personally identifiable data, we call that PII, personally identifiable data. That is the paramount for us. So, right, so we should not have any situation where a customer's data is getting leaked or stolen from our system. Could have happened elsewhere, but within our system, it should not go out. That is our paramount objective. So all the systems that is in place, when I talk about bots trying to access the APIs, or someone trying to send a malware to us, eventually trying to get into the system, all this threats and the preventions that we put in place, our major goal is to see if there is any player information leaking out, right? So I'll tell you a situation. We have, you guys know about TASMAC in Tamil Nadu, right? The Corporation for Alcohol. Similar to that, we have something here. It's called Alberta Gaming Liquor Corporation. So they had a website, and customers can log into this website to enroll into gaming and all that. So what happened? There was a vulnerable API, and the attackers using bots was able to exploit that API. They actually got personal information out, and they demanded ransomware to the government agency to release that information. And we have to go and put some systems in place and prevent it and all that. So to answer the question, PIA data, all this that we're talking about, it's just not to protect the entity or the company from financial loss. It is also to protect the PIA data from getting stolen from the company. Did that answer your question, T? Any follow-up on that?
Answers? Would like to hear from you. There's one more question from Dr. Ponduji. Madam has asked a question now. Generally, if we become a premium user of Chat GPT, how secure will our data be?
You want to know the truth, or you want to hear what OpenAI says?
Both.
The truth is your data is not secure.
Fine.
Okay. But what do you want to hear from OpenAI? They will say your data is secure. Very, very unlikely. The large language models are operating based upon data that is available in the internet. That includes your data as well, right? So they say they put in place, they don't use your personal data for training their models, but under the hood, they would still be using. Okay, don't quote me on this for anywhere, but that's the truth, team. So in industries where they deal with sensitive data, sensitive financial or the PIA data, they don't allow the staff to use large language models to process any personal information or any financial data. So it is completely barred, just so that you're aware. Yeah. But even for general users, like general users outside of these organizations, we should not be sending, and for example, I should not say, I'm just putting out in a hypothetical use case. This is my username and password. Do you think it is secure? If this question goes to ChatGPT, you can be 200% guaranteed it is definitely sitting in the database and somewhere they can use that information.
There's another
Right.
question. Can the use of multiple AI tools lead to any cybersecurity risk?
We got to use it with caution. It is evolving as we in this day and age. It is definitely still evolving, right? So even it's my personal opinion. No one can 100% guarantee that your data is secure. So when you use it, you have to use it with your caution. As I mentioned, you're not supposed to send any sensitive personal or banking related or anything of that sort. We should not directly feed into the tools. Let's say you're working on ChatGPT. You're not supposed to share any personal information. If you're having a bank statement, I would definitely recommend not to upload the bank statement to ChatGPT and tell it to summarize your budget. That is definitely a huge vulnerability right there. But you can still use them with your own discretion. You can give non-sensitive information and ask it to do the same. But directly sharing banking data or any sensitive information is definitely vulnerable, team. If you actually go through the T's and C's, you can do this. You can copy the terms and condition, give it to ChatGPT and ask it, am I being protected by this T's and C's? I'm very sure the answer is going to be no.
Thank you,
Right.
Mr. Karthikeyan. Yeah.
Awesome. Yeah. So we have a little bit more to cover. I'll try to skim through some of the theoretical aspects. So Stride is another threat modeling that we use in industry. Any project that we're releasing, this is the models that I spoke about earlier. It's more of an enterprise level models, right? The meter attack model, and the Lockheed Martin, the kill chain, cyber kill chain that I spoke about, the diamond model. These are like enterprise level. When let's say you're starting a new company and your company has grown into a 3,000 staff, multi-million dollar company, you should be having one such model being established in your company. The Stride threat modeling is more of every single project that we release. Actually, we do a Stride threat modeling to make sure that project is secure, that the software that they're developing is having all the security measures in place. I'm not going to go through every single step here, team, but at a very high level, we ensure if the APIs, the database, the processes that we have, does it have any open endpoints that an attacker could exploit? Are there any capabilities of someone doing something and just erasing a trace of it? It's similar to like a crime scene. If a criminal gets into a place, does something wrong, and then gets out and then erases all the evidence of them being there, that is also a bigger problem to solve, right? So if something happened, we should know what happened. So repudiation is one key problem that we always be wary about. Even if an attack happens, we should have sufficient traces of what happened so that we can prevent it from not happening again. So the Stride modeling is an industry standard that is being followed by most of the big companies right now, and it's developed by Microsoft. You can go search for it in the internet, you will find more details. So this is something that we follow on a regular project delivery basis. Just want to give an idea on it. Right. Data access policies. I'm sure bigger organizations, even in your college, you'll be having certain data access policies. Let's assume you have a database of all your students and staff, their payroll and all that. Those type of data should not be visible to anyone, right? So for example, if I talk about staff salaries, for example, the senior leaders should know about it. It should not be accessible or visible to everyone in the staff, or everyone in the payroll department. Only the senior most should be able to see the salary information of the staff. I'm giving an example like that. So that's data access policies. That the team should be still able to access the data, but there should be sufficient controls in place in terms of what data they can see within that, what elements they can see within that. There is a term called fine grain authentication, FGA. What it means is, even though I can see the staff's profile, certain parameters of it, like salary could be one sensitive thing. So salary will be hidden for me. I'm a payroll processor. I should be able to see it, but my staff who takes care of attendance should not be able to see the salary, right? So that's an example of data access policies. There is the many levels of details to it, but I just want to give an idea. This is one key item that we take care in the industry in terms of governance and controls on data itself, the data that we have. So one thing that I want to put out is, in the event of an attack and a cyber attack, the first suspect is within the organization. We would be scoring, and we'll be scanning every single access to data and systems within the organization. First, we'll make sure that that attack or the leak did not happen within the organization, and then we'll go out uh, to see if that attack came from external. So the primary suspect unfortunately, the primary suspect would be within the organization. And we have seen that happening most often as well. So most situation, the primary suspect has been within the organization too, right? So that's where data access policy becomes very crucial. And I guess I'll touch on the chat GPT question as well. So what happens is, because these LLM models have evolved now, it becomes very easy to it makes our work easier as well. I could simply copy my staff data, like with all the information, and give it to ChatGPT and ask it to summarize and give me a dashboard, all that. ChatGPT could do that, but essentially what I'm doing is I'm copying my company's data, organization's internal secure data, and then giving it out to the world. Once it is with ChatGPT, OpenAI, it is actually feeding in a way their large language model. You would not I mean, they could tell that it is all protected and all that, but in a way it is with them. They have their embeddings, and someone within OpenAI, if they decide to screw the company OpenAI, they can actually steal all this information and send it out, right? So at that point, no one can control what's going on. So that's where using these language models to process sensitive data is getting critical, and that's where this data access policies also comes into picture. All right. For a kick, I'm just going to talk about some of the recent cyber incidents that happened. This will give us a good lesson, right? So if you look at it in the last 5 years, we could see these fraud analytics teams and products that is out there. They are growing exponentially. They're making a ton of money. It's all because of these type of incidents that happened recently. So SolarWinds, I spoke about it. So they are infrastructure management software. So they had some of the attackers could get in a malicious code into their software, and that brought down SolarWinds. In a way, they brought down almost like 18,000 organizations across the world, right? And the worst part is they were within the system for almost like 9 months, and either SolarWinds or the companies using them, they were not aware of it, and they don't even know what actually has been stolen, what's been taken out. That's because of the repudiation step that I spoke about in the stride model. So that's seriousness of making sure even if you're vulnerable to attack, we should be having enough evidence of what happened. So that's SolarWinds. That's a huge loss for SolarWinds. Their stock price went down. I don't think it came back anytime sooner. So it's still down actually. So MoveIt is a file transfer. So file transfer system, they also had a similar type of an attack. Uh, it's a software that's widely used across organizations. Those would be the primary source or candidate for these attackers, right? So if they attack them and they're impacting many business and they can claim any ransomware. So they spent almost like $10 billion across. This includes British Airways, BBC, all the top industry players. They all have to spend a ton of money to come out of this problem. MGM Resorts, I spoke about it. It's man in the middle type of an attack and social engineering. So someone called the front desk and somehow got connected to the IT team, reset the password, and they cost a $15 million damage. Cloudflare, we spoke about it. So this is one of the recent attacks that I was astonished of how dependent we are in these type of systems right now. It is like locking ourselves outside and not being able to get in. So I have the most secure door in the world. I put an ironclad iron door in my house and I lost the key. What happens? The secure door is not purposeful anymore, right? So I could not get into the house, and no one can get into the house. That exactly happened with Cloudflare breach. So we all trusted a software, and that's being used across many organizations in the world. And something happened to Cloudflare, and no one is able to get into. No one was able to operate the business. So that was a huge win for the attackers and huge loss for every one of us, depending on one single solution provider. And a couple more. The CrowdStrike is a recent one. That is also the same aspect. It is actually not an attack itself, the CrowdStrike one. You guys would have been aware of this one. So many hospitals, banks, uh, immigration department, everything went down because of this CrowdStrike. CrowdStrike is another application firewall layer that monitors and detects traffic. Something happened to it. It's not an attacker, it is a Microsoft patch that messed up their servers, but that brought down the entire world for a few hours. So that's another event of not trusting us, even though we have the most sophisticated SOC team and the processes in place. We should still think about failover mechanism. Failover is, what if my iron door key is lost? How am I going to get into the system myself? Right? So that's failover. So that's another thing. While we talk about all the systems, cybersecurity, protection, all that, we should also be focusing on a fail-safe entry point for us. That's a lesson learned, a lesson that the entire world learned after the CrowdStrike attack. All right. A quick time check. How many minutes we have, Shaman?
Yeah, 5 more minutes.
All right. So all the topics that we discussed, I just want to quickly touch on some of the off-shelf tools that we use. There are tools that monitor digital identities and then fraud scoring. I spoke about it in the couple of slides before. We attach scores based upon where the transaction is coming from, who's doing the transaction, all that. So there are tools out there. For example, we use a tool called LexisNexis. It is basically you all be familiar with the term know your customer. So this tool, when a customer is trying to register into the platform, we give the information to the solution provider. They give back a score from 0 to 1,000, and the more the score, more risk it is, and we still keep track of it, and we determine if the risk is 300, we still continue with the registration. If the risk is more than 800, we block the registration, kind of a deal, right? So there are tools out there that does it. And bot deduction, I think every single cloud provider right now have bot deductions in place, and firewalls have bot deductions in place. They monitor the type of traffic, where the traffic is coming from, what is the origin, like what is um, so if the request is coming from a mobile, if the request is coming from a web browser, there is something called origin identifier they track the origin identifier and see, okay, whether this is a legitimate transaction or not, and then block it. As I mentioned, when we enable bot production, we immediately saw like 40% of the traffic is getting slashed out, meaning all the 40% of the traffic was actually bots that we saw live in our projects. AML and watch list screening. It is AML is nothing but anti-money laundering. These are regular things that the banking does to make sure the transactions are not done for whitewashing the money. And KYC, I spoke about, know your customer to get some risk scoring based upon the customer's profile and so on, team. And one interesting thing is dark web monitoring. So some of these tools that is available out there, they will be able to help you with dark web monitoring. Meaning, if let's say a user is using an email, let's say a student is using an email to register themselves into a student portal, these tools can help if this email is part of a dark web, right? So dark web is so they can check these dark webs, and they have a database of all the exploited or vulnerable emails, and they can prompt you, okay, this email seems to be having some presence in the dark web, and potentially we should block or flag the user.
Excuse me,
So
excuse me, Mr. Karthikeyan, there's a question.
sure.
For penetration test, which software tool can be used in the data center for doing complete pen test, or routers, radio modem, SAN storage devices, or rack servers, etc.? We want to have the latest best tool available. That's a question from Mr. Ganapati.
Mhm. So penetration, when it comes to penetration testing, Ganapati, I mean, again, I don't have the specific tools. I'm not recommending specific tools. We use multitude of tools right now. For example, if I have a slide on that as well, one moment. Right. So I think this tool that you have here, Metasploit, that's a common tool that I've seen in the industry being used in the industry. But when it comes to pen test, it's not about the tool. It's about what are we trying to exploit? What are we trying to uh, uh, in what model we are using. The stride model is the model that we need to use. What are the areas of focus that we need to see? It is as simple as, is that API having any vulnerabilities? Meaning, can I access the API without the session ID? Can I access that API without passing the proper credentials? If I use even if I could get the session ID, what is the time to live for the session ID? Typically, the customer session ID should not be living more than for 15 minutes, meaning even if an attacker can get session ID, they cannot use it after 15 minutes. It should expire. So that type of an engineering is what I would recommend to focus on than the actual tools itself, because the tools are going to evolve. I mean, I could give you 10 different tools. I mean, um, we use in-house developed software for penetration testing. CrowdStrike offers many tools for penetration testing as well. And we use what is it called? We use a tool called Group IB for doing some penetration testing. So there are many tools out there, but what we need to focus on from an academia standpoint is the threat modeling itself. What should we be looking for? And what are the common trends? How do we protect it? So that should be the focus area, Ganapati, if you ask me.
Thank you, Mr. Karthikeyan.
Yeah. All right. Um, all right. Let's reserve the last 5 minutes for any other questions, team. I think I have a few more, but I think we're going to run out of time. We could
Yeah.
cover in another opportunity, but
Sure.
I'll take any more questions. Yeah.
You're looking for questions from the participants? Dear participants, the floor is now open for the questions from you. You can post it in the chat box, or unmute your audio and post your questions. We are running short of time. Any questions? There are comments in the chat box. Participants, please feel free to share your queries or reflections. We have a very distinguished speaker with us. Would like every one of us to utilize this opportunity. No questions. Yes, Mr. Karthikeyan.
Yeah.
Shall we sum up?
Yeah. Fair enough. All right, team. Thanks a lot. I think I did had a slide that actually talks about what you guys do from an academic standpoint, what industry actually looks like.
Yeah.
I'll just spend 2 minutes on it, and then we can
Sure.
wrap it up.
Yeah,
Yeah.
sure.
So yeah, I mean, I think from an academic standpoint, we are focusing on what could go wrong, and based upon a syllabus that's been created like a couple of years ago and 3 years ago, the industry is going in a pace right now. Like if you learn something in the morning, something is changing in the evening, right? So things are moving in a very, very fast pace. That's what I made a point in terms of don't focus on the specific tool, but focus on the model itself, the framework itself. That's going to help your students understand what is the problem statement and how they could solve it when they get into the industry. So things like the meter attack model, it's a global library of all the attacks. If you look at it, the attackers could use new tools as well, but psychologically, from a human evolution standpoint, all the attacks are going to have the same intention and the same modus operandi. So if we know that the tactics, techniques, and the procedures they typically follow, then it becomes easier for us to find identify the tools and then solve it, right? So that's where I keep focusing on the model. So that's what would help the students to understand what it is, because they could learn a tool, but by the time they come out of the college, the tool will be obsolete. That's a trend right now. So don't focus too much on the tools itself. And Deduction logic. So one thing, this is very interesting. The behavioral analytics. This is also evolving in the industry, as I mentioned. So things like user logging in at 3 a.m. from a new country after 9 to 5 years of activity. In the past, we never looked at these things. All right, so these type of patterns were never looked at in the past. 6 years ago, even myself, we have not thought about it. But now these type of behavioral anomalies that we may call it are the key items that we look for. So what patterns could actually contribute a transaction to be a fraud versus a non-fraud, right? So we use machine learning models a lot in this space. We give all the transactions, obviously masked transactions. When we give all the transactions to a language model, we take the due diligence to mask all the private, personally identifiable information and sensitive data, and just give the date, the pattern alone, right? And then let the language model, the machine learning, tell us the pattern and flag suspicious transactions. So and It is more easy with the Gen AI tools right now to create fake identities. So anyone, you could ask the customer to scan their ID, and they could definitely, just in a matter of minutes, they can actually print 1,000 fake identities and use them to enroll. Our government processes may not be robust enough. The ID numbers could be easily spoofed. So anyone could create a fake identity and use that. In the past, only we had to actually deal with someone to create a fake identity, but now it's easy for us to just do it with a laptop, right? So we need to focus more on that and think about how we can protect the industries that we get into. So that's a key difference, team, in terms of what we read from an academic standpoint versus what we actually see in the industry. So, from an academic standpoint, we look at the past trends alone, and we don't understand. We don't try to. We just need to try to equip the students to look at what's the current trend, and basically give them the framework to get into the industry. These are some of the certifications out there. I'll share this deck. Maybe you guys can take a look, and then
Yeah.
I'll be open to any
Please
questions that
share.
you might have.
Yeah,
Yeah.
that would be a great idea. Would you please share the slides with this so that we will be able to pass on to all the participants?
Sure. Yeah.
Yeah, that's fine.
Already. I have a few more, but I think we're running out of time.
Yeah.
Thanks a lot for this opportunity. I'm glad I'm able to share some of my insights. Hopefully, it was helpful.
Yeah, thank you, Mr. Karthikeyan, for your insightful session. It was really interesting on industry cyber threat landscape, the use cases, the skill requirements, and workforce expectations. I think we need one more session on it very soon from your side. Let's plan for it again. And your practical insights and clear articulation, actually, it is for the current threats, the workforce. It has offered all of us a valuable perspective that is new to us, really. We sincerely thank our management, our chairman and vice chairman for their really constant encouragement and support in organizing these types of FDPs and programs. It's actually their vision and guidance that keep continuing us to inspire to create all this meaningful academic and professional engagements. Thank you, everyone. Thank you, everyone, for your active participation in today's sessions. Any questions, you can post it in the chat box or you can ask Mr. Karthik. And almost we are at the end of today's session. So in the coming days, we'll keep continuing to explore new perspectives. Our speakers are not only sharing their expertise, but also the challenges and also the emerging directions in this evolving field. I encourage all of you to stay engaged, ask questions, and make this a true learning community across the continents. We have speakers from across the continents. We have participants across the continents. In fact, it's a great honor to have you, Mr. Karthikeyan, for making this session a great, interesting and valuable session, taking us to the industry. Thank you so much. Thank you. Thank you.
Thank you all.
Thank you.
Bye.
Bye. Thank you.